All right, welcome to day 5. I'll be your host, Mr. Brislin. Whether you like it or not, I'm here. All right, so we have the exit ticket from day 4. First off, I hope everyone had a great weekend, enjoyed the weather. If you haven't picked up on this yet, I've made this video before the weekend. So you're watching this on Monday when the weekend's already happened. I believe it's supposed to be really nice on Saturday. Let's hope that that's the case. So let's pretend it already happened. It sounded like Saturday was a lovely day. Hope you enjoyed your day on Saturday. I did. I'm going to. All right. Here we go. Number 1, 8 times 1/3. This was number 1 in the exit ticket. 8 times the 1 gave me my new numerator of 8. Keeping the denominator of 3, 8/3. 8 went into 3 went into 8 2 times. I got 6. I subtracted. I got a numerator of 2. And my denominator was 3, so 2 2/3. For number 2, we get a mixed number of 3 1/3 times 4. All right. So 3 1/3 times 4, we are going to get 3/3 times 3. And that'll become 10/3 plus 1. I'm sorry, 3/3 times 3 equals 9/3. Forgot that, write that down here. Plus 1/3 gave me my 10/3. I'll take 10/3 times by my whole number of 4 to get 40/3. 3 goes into 40 13 times. Well, how did I figure that out? 3 went into 4 one time with subtracting 3, because 1 times 3 equals 3. I get 1. I bring down the 0. Now I get 10. How many 3's go into 10? 3 of them. 3 times 3 equals 9. I subtract. I get 1. Therefore, that's my numerator. So 13 1/3 is my answer for number 2. All right, so let's jump in right into today's lesson day 5 NTI. So we have Jake here who collected 3 3/8 gallons of milk from each cow. If he collected the same amount from 3 cows, how much milk did he have in all? So I have 3 cows. Let's pronoun Jake. 3 cows. Each of them is supplying 3 3/8 of milk. 3 3/8, 3 3/8, 3 3/8. So I could just add 3 3/8 3 times. But we're 5th graders. We're not adding multiple numbers. We're not doing repeated addition. We're using multiplication. So here's how we're going to do that. Same thing as we did last week, but now it's just in word problem form. 3 3/8. We're going to turn that into a improper by doing 8/8 3 times. All right. Then we're going to get 24/8. We're going to add the 3/8 to get 27/8. Don't forget that fraction of 3/8 there. I'm going to add it to 24 to get 27/8. Times that by 3. Whew, I'm going to be at a huge number. All right. 27 times 3 will give me 81. Find out how many 8's go into 81. You'll find out that 8 goes into 81 10 times with 1 left over. So therefore, that's my numerator. So 10 1/8 is my answer. 10 1/8 what? Apples? No, 10 1/8 gallons. Don't forget to label and provide your units. Gallons of milk. It's a lot of milk for Jake to be collecting. All right, so now we're going to move on to the next problem I would like you to solve. So we have Kelsey collected 2 3/4 cups of water from each student. If she collected the same amount from 5 students each, how much water did she collect? All right, hit that pause button and go ahead and solve this problem. We are now back. 2 3/4 is going to convert to an improper fraction where I'll take 4/4 2 times and get 8/4 plus my 3/4. 8/4 plus 3/4 gives you 11/4 times the 5. 5 what? Well, we have 5 students. So Kelsey, remember, she collected 2 3/4 cups of water from each student. There's 5 of them, 2 3/4, 2 3/4, 2 3/4, 2 3/4, 2 3/4. And no, we're not using a repeated addition here. All right? But Mr. Brisland, you're so mean. I know. I'm a mean person. I'm making you use multiplication. It's tough. All right. So 11/4 times 5 will give you 55/4. So I'm going to use long division. How many 4s go into 55? How many 4s go into 5? 1. I get 4. 1 times 4 equals 4. I subtract. I get 1. Bring down my 5. How many 4s go into 15? 3. So then I get 12 when I do that. I subtract. I have 3 left over, which is my remainder or my numerator. Since I want to know a mixed number, I'm not looking for a decimal answer. 4 goes into 13 3/4. I'm sorry, 4 goes in to 12, you got the 3. Denominator is going to be 4. Numerator is going to be 3. Therefore, it's 13 3/4 cups of what? What are we talking about here? Cups of water. Okay, she'll have collected all together. All right, next problem. We're talking about Garrett. All right, Garrett collected 5 2/3 pounds of dirt from 3 different bags each. Bag 1, bag 2, bag 3. How much dirt did he have in all? Go ahead, hit the pause button and solve this problem now. Aha, switch slides on you. All right, so 5 2/3. I'm going to change that into an improper. Probably getting tired of me saying the same thing over and over again. Okay, I get it, Mr. Brisland. I got a mixed number. Turn it to an improper. Well, good. I'm hoping it's getting stuck in there. Hoping it's getting stuck right in there. All right. So 3/3 times 5. Why am I using 3/3? Mr. Brisland, I know this already. Good. That's awesome. All right. So we're using 3/3 because 3 is my denominator. 3/3 times 5 will give me 15/3. Plus my fraction of 2/3 will give me 17/3. Times 3. 3 different bags. Therefore, I'm going to take 17 times 3 and get 51. How did you do that, Mr. Brisland? 17 times 3. 3 times 7 equals 21. 3 times 1 plus 2 equals 5. 51. 51/3. Something seems fishy here. 51, as you probably hear me say over and over again, is a composite number, and it gets everybody confused. Okay? It's when you see, is this number prime or composite? And you will see 51 on a test, probably like a K-Prep test. All right? It stumps everybody because it's an odd number. Most students will think, oh, it's prime. No. What we're going to find out here is 3 goes into 51, and it goes in 17 times. All right? So we end up getting 17 pounds, a whole number. Wait a second. I thought we were trying to come up with a mixed number here, Mr. Brisland. Well, coincidentally, in this specific problem, we end up getting a whole number. Nothing left over. We sometimes get lucky like that. All right. So altogether, we have Garrett who collected 17 pounds of dirt. Not sure what he's using dirt for. but he collected 17 pounds of dirt. All right, so with that being said, let's move on to our last and final problem. We have James. He's collecting 3/8 of fluid ounces of liquid from each bottle for his experiment. If he collected the same amount from 5 bottles, 1, 2, 3, 4, 5, 3 and 3, 3 and 1/8, 3 and 1/8, 3 and 1/8, 3 and 1/8, 3 and 1/8. Okay? How much fluid ounces did he have in all? In all. Okay. Go ahead, hit the pause button, and solve this problem now. All right, we're back. 3 and 1/8 is going to turn into an improper fraction by taking, you guessed it, 8/8 times 3. Right? Then I'm going to add 1/8 to that because I get 24/8. When I do 8/8 times 3, I add my 1/8, I get 25/8. Now I'm doing 25 times 5. How many? 25 times 5. Well, some of us might be able to do 25, 50, 75, 100, 125, which is awesome. Some of us might be able to relate this to money and 25 being a quarter and realize, hey, that's $1.25. Okay, awesome too. And some of us might just need to use some standard algorithm here to figure this out. So 25 times 5 will give you 125. That's my numerator. My denominator is 8. How many 8s go into 125? All right. Well, my 8 times tables you may not be fluid at. So I'm going to write them down just to make sure I don't make, I've gone so far, I've gone really, really far. Why would I want to make a silly little multiplication mistake at the last final steps? Right? So 8 goes into 125. 8 goes into 12 specifically one time. You get 8. I subtract, I get 4, which you can't see right now. There we go, 4. I bring down my 5, I get 45. 8 goes into 45. I think it's 5 times, but let me check. 8 times 5 equals 40. Yep, bingo. All right, goes in 5 times. 5 times 8 gave me 40. I subtract, I get 5. 8 times 5 well, 8 can't go into 5, so that's my numerator. Denominator is 8. 15 and 5/8. What? What are we talking about? 15 and 5/8. Go back to the problem. Fluid ounces. Bam. All right. So now, if you're not feeling confident, don't go to the exit ticket yet. Go back, look over these problems, maybe even make up a problem, practice it. But when you feel confident, move on to the exit ticket. And I can't wait to see your results. All right. Best of luck, and we'll see you back here tomorrow.